Hello, good morning. Let's start today. All of you can hear me?
Yes, Vinny.
Okay. All right. So today we'll talk about Scoop. Scoop is a tool which allows data to be moved from relational databases to Hadoop file system and also from Hadoop file system to relational database. So why is this so important? Because for any tool to succeed, it has to work with the enterprise. So the enterprise data has to be somehow managed. So generally, if there are companies who are working on the social data, right, Twitter data or Facebook data, they don't go into relational database. They go to NoSQL databases. But enterprise, pretty much most of the enterprise have enterprise data warehouses, Oracle databases, or IBM databases. So it's important that data can be managed properly from the enterprise to the Hadoop file system and also vice versa. Okay, so data management is the key part, is the key for the success of Hadoop. Okay, so one such tool which is used for data management is Scoop. Okay, so as you see here, the very first slide, Hadoop data processing has a couple of components. So where is Hadoop data in the first place? Hadoop data can be processed using Pig, Hive, or MapReduce, or HBase, or Mahout, right? So we have seen so far MapReduce. Since MapReduce is a paradigm where we run MapReduce programs and which will have the data available in HDFS. Okay, so the whole core framework is MapReduce, which is the compute part of the Hadoop, and Hadoop file system, which is the storage part of the Hadoop. Now, rest of all other tools are built on these two frameworks, right? So the rest of all the tools are built on the other frameworks. For example, Pig, Hive, HBase, Mahout, or you name it, Scoop. Every tool is built on the top of these two. That's why we have spent a lot of time understanding Hadoop file system and MapReduce. So Hadoop has to coexist. Hadoop file system or Hadoop has to coexist with the other data sources. In this case, we're looking at relational databases, document-based systems, enterprise data warehouse. These are the other kinds of data that are there in the enterprise. Okay. And one of the requirement is that we should be able to import data from external data stores into Hadoop. For example, in this case, we have relational database, document-based systems, and enterprise data warehouse. The data from these systems can be imported to Hadoop file system. Generally, if we have 2-3 terabytes of data warehouse, they should be able to import easily into Hadoop file system using a import system, right? So how the import works is basically to take a look at the tables inside the relational database system and copy the rows from the tables into Hadoop file system as one line. Okay, so we will see how that goes. So pretty much this is the important slide. There is one more slide. You also want to export data from Hadoop file system to external data stores. So generally after processing, the output of Hadoop has to be pushed to some place. So either it can remain in Hadoop file system or it has to go into some database where from there the other applications can pick up and then interpret the data. So for that reason, we need a Scoop export. So in this slide, you see both import and export happening from relational databases to Hadoop file system and from Hadoop file system to relational database systems. So in terms of the components inside the data processing, right, HBase is a columnar database on the top of Hadoop file system. So we will not cover HBase here, but we will cover Pig, Hive. Okay, So pig is a data flow language that can query Hadoop file system. Similarly, Hive is a SQL-like query language on the top of Hadoop file system. So as administrators, we need to know, definitely that we need to know how to issue some queries on Hive and pig, at least the basic queries. Because even though you may not be working as a full-time data analyst, but you would need to know whether you will be able to query or a particular query is working or not, things like that. So for that, we need to at least have some introduction and also try a few commands on pig and Hive. So we will, in the next few classes, we will be touching some pig and Hive. Okay. So these two tools, pig and Hive, form the core part of data analytics. If somebody is serious about writing some, or working on data analytics, they should learn these tools to process data on Hadoop file system. So the way it works is generally the enterprise data, either it is from relational databases or from anywhere, or any other external system, or any log files in the enterprise, or any document can be pushed to Hadoop file system. So they don't think twice. Hadoop file system is like a trash can. So you can just push whatever you like. You just copy the files or copy the data from the tables. You just have to manage the hierarchy of the data in Hadoop file system. That's all. So then once it's imported into Hadoop file system, it's going to be there forever. And it can scale. It can scale to 20, 30, 40, 50, probably hundreds of terabytes. Right? So now once you have the data, what do we do with this data in Hadoop file system? We need some tools to analyze. So that is where the pig and Hive are coming as tools. Okay. So HBase is a columnar database. HBase, you can think of HBase as a database again. It works on the top of Hadoop file system, and it provides the ability to store data in terms of rows and columns, okay, as a logical structure, similar to Hive. But HBase is more scalable. It provides update operations on the system. It provides update operations on the data. Okay. Have you heard about Mahout before? No. Okay. So Mahout is a machine learning algorithm library on the top of MapReduce and Hadoop file system. So what does Mahout do? So you must have seen that in Amazon.com and Netflix, when you browse for items, they would recommend items based on the books you are browsing. So that is called item based recommender. So what they do is they use something machine learning algorithms to find out the behavior of users with respect to the items that they purchase. So when the behavior of users is known, then if I bought a book on Mahout, somebody who is looking for Hadoop, they will present a menu saying that users who have bought this book also bought these other books. Okay, so something like recommendation. So for example, based on what kinds of, for example, if I know for the past 2 years what kind of movies you have seen frequently in Netflix, then based on what kind of movies you have seen, is classical movies, fiction movies, or action movies, I can recommend further movies to you when you log into the system. So that is called recommendation. So this kind of recommendation systems are done through machine learning. So machine learning is basically just look at the data, analyze the data, and then try to draw some inferences from the huge amount of data. So that is Mahout. Okay. So how Scoop works, right? So if you have a data like this, right? See you under customer orders, for example. You have a customer ID, customer, sales rep. So the same data which is there in tables will get transferred into Hadoop file system as lines. So every row in orders is transferred into Every row in orders is transferred into Hadoop file system as a line. So you can specify which directory you want to import, and in that directory you can see the data in terms of lines. So in Hadoop file system, you will be seeing this table as a file when you import it. So you can also think of partitioning the orders based on the size of the table, right? You can decide to partition based on set of IDs. Set of IDs can go into one partition, and then another set of IDs can go into another partition. That's what it is trying to say. Now, how does it work? Right, first the orders. So it uses the Scoop uses the basic MapReduce framework again. So under the hood, it is using MapReduce. So it is not using anything else. It is using MapReduce. It is using the power of MapReduce to copy the data from relational databases to Hadoop file system. How does it work? So once you have the orders, you do an input split, just like a MapReduce program. Then you run the mapper. So what does the mapper do? Selects the data from that split and then pushes into the Hadoop file system. That's a very simple system. So again, from the table, if the table is huge, split into pieces, and then for every piece run a mapper, and the mapper will connect to the database, get the records one by one, and push it into Hadoop file system. So we will see the example today, how this works. You can also say that I don't need column 3. In this case, for example, customer orders, right? You have n columns. Okay, you can decide to choose very specific columns. You don't have to copy all the columns data onto Hadoop file system. You can also do a join. So for example, if you want to do a join of orders and customer, you have to join in SQL, and then output of the join will go to mappers. So the mappers will not do the join in this case. The join has to be performed by the SQL beforehand, and it could be just a query. It need not be it could be a join query that will be used to join these two tables. And then once the result set is available from the SQL query, and then from there mappers take over and then copy the data to Hadoop file system. So this is a overview. So pre-processing. So before pre-processing, then there is a data transfer and post-processing. So in pre-processing, you have to select the connector. So if you are using Oracle, you have to use Oracle connector. If you are using when a MapReduce is submitted, right, the code is generated automatically. The MapReduce program is generated based on what you have selected. Okay, so what it means is, if you see here, orders and customer and SQL here. So because this is so dynamic, it has to work from whatever tables that I am passing in, whatever query that I am passing in, right? So the MapReduce code, the mapper code, cannot be static code, because it has to look at different files, different formats, different databases. Hence, what the Scoop does is, it generates a MapReduce job, or it generates a code, Java code for MapReduce job. That is the code generation part of it. So once you identify which connector, let's say I'm using Oracle connector or MySQL connector or PostgreSQL connector or Teradata connector or any other connector, okay. And this lot of databases are supporting connectors now. They're already there. People are supporting connectors and they're already there. So in this case, once the connector is selected, then the Scoop framework generates the MapReduce Java code, compiles it. Once it is compiled, then it is configured. Once everything is ready, then a job is submitted. When the job is submitted, then data transfer takes place. Once the data transfer is complete, then you have to do a cleanup, and if required, you can also import data into Hive. You can also import the data into Hive tables, and then you can query Hive tables. As you can see a little bit more details in case of pre-processing, you will see first you identify the connector, and then what the connector does, it does a lookup onto the relational database table. Lookup onto the relational database table. So what it means is, it looks for the metadata of the table. What is the metadata of the table? It says what are the columns and what is the data types. So the SQL types and Java types are being interpreted. And then once you know the metadata, you will do select statement from the table, right? And you get result statement, result set. Once the result set is available, then that output, each result set record is called as a scoop record, and that is passed to the MapReduce job. The code generation part, right? Scoop, you can see that there is this scoop record, which is a Java class that is being generated on the fly, which consists of, in this case, set of columns from the relational database. Okay, so the scoop record will get pushed into the Hadoop file system. Again, this is a little internal, you don't have to know about it, but I will demonstrate to you how you can use scoop so that you will be hands-on with scoop. That is the purpose. So this is a little bit internal. It is not required to know. Only those people who are developing scoop connectors, they would know. Otherwise, it is not required. So this is how the mapping between relational database types to Java types. So integer is mapped to java.lang.integer, decimal is big decimal, numeric is big decimal, boolean is boolean, date is date, things like that. Okay, and then how does the data transfer happens? So you would see that there would be a input format, and each input format will process. You can see here data driven DB input format. You have a get splits, you have a list of input splits available, then you have a create record reader and things like that. So what is happening here is the data which is there in the relational database is split first in terms of splits. Then for each split, you will see a mapper being created, a map task being created, and the Java classes for this are mentioned here. Again, as I said, it is not required for you to be knowing all this, but for those people who are little curious what is happening, is just like any other map reduce task, we need to first get the data split. If the data is huge, first the input splits are formed. Once the input splits are formed, you can see that the class that is providing input split is this one, data driven DB input format. That is a class that provides the input splits. And then once the input split is available, for every record in the input split, for every row in that split is given by the record reader. That is called data driven DB record reader. So this is the one that gives the every row in the table is given as output, or this is the record reader that reads the every row from the database and pushes it to Hadoop file system. Then that particular line or that particular row is converted into scoop record, right? That particular row is converted into scoop record. And then once the scoop record is available, then the map task will run and then convert that into output format. And the output format could be anything. Output format could be the format that you choose. In this case, it's a text output format where it will be comma separated values can be pushed into the database. So again, you see here, submit a job, you have the input format, you get list of splits, and for each split you have a map task, and for every map task there is the output format, and then the output is pushed into the Hadoop file system. And the output format could be a text file, it could be a sequence file, it could be apr7 file. So again, they're just files of different, how people manage data differently. So it could be plain text file, or it could be apr7 file also. So the data transfer, how the data transfer happens. Sometimes if you're doing dumping the whole database or dumping the whole table, the second okay. So the other way is that they also has a import format, which is dump import format, MySQL dump, and then you also have a record reader for dump, and then the output of that would be again MySQL dump mapper is there, and then it does a copy and a sync, and then the file out format again. So there are two ways, right? One way is directly use the DB. The second one is use a tool called MySQL dump. Okay, use a tool called MySQL dump. So in the post processing, right? So again, we have not touched Hive, but I will tell you a little brief about it. We will touch Hive tomorrow or day after, mostly tomorrow. Sorry. So the post processing, how it happens? So once the data comes here into the Hadoop file system, right? So the connector that in this case the Hive connector, right, is looking at the definition of the data, and it creates a table. It creates a Hive table, and that you can see the Hive script is there that creates a table. That table is stored in the meta store, and the data goes to Hadoop file system. Okay. So again, basically what we're trying to do. There are too many things in this picture. So data from the relational database system is copied to the Hadoop file system. That is one. That is what we have seen in the previous slides, right? In this slide is slightly different. The same data is not just copied to Hadoop file system. It is also being managed by another system called Hive, where the data in the file system is exposed as tables for other users to query. So we will see the example, then you will know. So these are different connectors that are available. Okay, you have Oracle connector, Couchbase, Netezza, Teradata, MySQL DB, Microsoft PDW, SQL Server, VoltDB. So there are so many other connectors that are available to push the data from the relational databases to Hadoop file system. Okay. So this is the road to Scoop 2 architecture. So before, Scoop 2 is just being built, so it is still not ready. But what we will do now is we will go through the actual commands. Okay. Any questions for you guys? So I will keep those questions with you until I complete this exercise. Okay, then it will be much more clear for you guys. So I downloaded Scoop. Okay. See here I have 3 versions of Scoop: 1.4.2 binary, Scoop 1.4.2.gz, Scoop 1.4.3_bin. So right now I'm using 1.4.3. So you can use 1.4.2 or 1.4.3. The only thing, that condition that you have to make sure is that it is there for major versions. For example, if you see here, I have Scoop 1.4.3 Hadoop -0.20.gz. So if you have a Hadoop version which is .20 then you would use this. Similarly, I have the same 1.4.3 for 1.0 also. Okay. So if you really want to see where they are, all of you following me? Any questions? So you can see here, you can go to nearby download and you can see, okay, there are various downloads available here. These are tags, but I think you can just say latest table download, and you can see here. Okay, here you can see 1.4.3 is having 3 versions. 4 versions rather: 0.20, 0.23, 1.00, and then you have 2.0.0. Okay, and the source code is there in 1.4.3.tar.gz. Okay, so all of you clear about these versions? So if you're using 1.0 of Hadoop version, you have to download scoop Hadoop -1.0. If you're using 2.0, you would see scoop -1.4.3 bin underscore Hadoop 2.0, and if you're using .23, you would use .23 version. If you're using .20, you would be using .20 version. Is it clear?
Yes.
Okay. So then what I did was I extracted that file. I did a tar-zdxvf. Please note down this command if you're not knowing before. Downloads. That's all I did. So I extracted the code scoop into a directory. Okay. So these instructions are there. Okay. I will send you the notes. Then it will be clear. Again, I think someone sent me a mail about the other things. I will send those notes today. Okay. Okay, so this is the first step. You can see here. Hope all of you are able to see this, right? Is it clear? Or maybe yeah. Okay. So I just downloaded and installed Scoop. Okay. Then I go back, and what I will do is I will just start my Hadoop servers. I'll start Hadoop.20.20. I use 0.20. You can use any other version, doesn't matter. So I just started Hadoop. By this time you should be experts in starting and stopping Hadoop, and you must practice this. So you can see that I have secondary name node, task tracker, job tracker, data node, all of them are running. So I will just do one more thing. I have some files that were done yesterday. Anyway, so we'll come back to that. So if you this is the key part. The theory is one part, and how to use is the second part. Okay. So how many of you have worked in MySQL before, or any other relational database?
Yes, Vijay, I worked.
Yeah, worked in MySQL. Yes, you made me.
So all of you are familiar with that, I hope, right?
Yes.
Okay, great. So then this is a piece of cake for you guys. So what I'm doing here is I'm going to start in my Mac. I'm starting MySQL server. Okay. So you can use Windows machine and you can start MySQL server. Doesn't matter, or you can use Linux box or anything. You can start. Now I'm connecting to MySQL. Right. So I'm looking at show databases. What are the databases that are available? We can see. Is it visible for you folks?
Yes.
Okay. Is it clear? Okay. So I want to drop database scoop _test. Okay. Now let's start So I have this data. I will just quit here. So I have this data called MySQL. Okay, so I'm here. I want to go to Hadoop and I want to go to scoop directory. So I have a MySQL data here. Okay. See here, MySQL data is here. This is a dump that is available for me. Okay, this is a dump of data that is available. So I'm going to use MySQL. So when you export data from MySQL, you can get a dump of 2 tables. Okay, so that is what this data is. So in fact, you can open and see what this data is. Right, you can see this is an input or basically a MySQL dump. So somewhere I got this dump. Okay, so I'm trying to import this data into Hadoop file system. Okay, that is my goal. So it has about 4 tables. Okay, it has about 4 tables, right? So what I'm going to do is again I'm trying to set this data. So this I'm still trying to be using so watch and ask me questions if you have any questions. I'm logging into Hadoop. I'm creating a database. Okay, scoop underscore test. Okay, now I'll quit. Then I'll import the data into scoop underscore test. Now I go to MySQL minus u root minus p, and then I go to root and then show databases. I should have then use scoop underscore test. Now show tables. You should see some tables here. Okay, so select count star, some Bible frequency. So I have 14,330 rows. Then select shake underscore frequency. This is 31,809 rows are there. Okay, so what I did is that in the enterprise system you would have database like this, MySQL database, and you would have tables like this. So now the exercise is, this is the setup I have. Generally this setup already exists from your existing warehouse or existing Oracle based systems. The data already exists. So I just showed you that I have data in MySQL now. Now what should I do next? So I want to push this data to Hadoop file system. So where is the data? The data is in MySQL database, and MySQL database incidentally is running in my machine, but generally it is not required to run in my machine. It could be a Oracle database running in Oracle server, or it could be a warehouse server, or it could be anything, or it could be a Teradata server also. So you can use this connector and use scoop for that. So this is the setup that I have got again. So don't get confused. I have a database called MySQL and I have 2 tables, Bible underscore frequency, Shakespeare underscore frequency. So these 2 tables consist of some data. Okay, so these 2 tables have some data. So incidentally this data is nothing but how frequently, what kind of word, it is nothing but a word count program. Okay, in Bible if you take all the words, what kind of words will be used how many times. That's what this Bible frequency is. Okay, if you see, actually select star from Bible underscore frequency, you would see, for example, all this testimony is one. All these words are used one time. So there may be other words that are used, right? So describe Bible underscore frequency. Okay, select where type is greater than 1, unknown column type the frequency. So there are 6,172 words, right, with the same word used more than 10 times. So we can see what are those words are, right? So let's see if there is any word that is more than 100 times used. There are these many words, 110 rows that are used for more than 100 times. Is there any word that is used more than 1,000 times? There are 137 rows that are used more than 1,000 times in the Bible. So this is very interesting. You see, the word Lord is used 1,003 times, right? And the word, for example, if you look at further, right, these are all words, thee, I, and my. These are all most frequently filler words, but most of the words are, except one or two, all of these words are useless, right? Because except this Lord or Henry, heart, rest of the words are filler words. Anyway, so that is not part of the the syllabus, or that is not part of the talk. But what I'm trying to say is, it's very interesting to know that if you open the Bible and you run the word count program, right, it will count how frequently, what kind of words are used, how much frequently in the Bible. So after some time you will see, right, this is the technology that Google uses, PageRank algorithm or whatever that they use for searching, right? If I search for Sachin Tendulkar, just see, imagine this, how amazing Google is doing, right? If I search for Sachin Tendulkar, you see what? I didn't ask for any of this data on the right hand side, right? You see his pictures, and then you see a cricketer, then it's giving you when he is born, what is his height, who is he married to, what is his salary, what are the awards, and who are their parents, right? So this is kind of, these are the technologies that are behind big data, and Hadoop is definitely, or for Google, they have their own MapReduce. They have not outsourced it, but Hadoop is open source and everybody uses Hadoop. But these are the technologies behind the big data. But anyway, that's besides the point. So now what I'm going to do is, I'm just going to, if there is any data, there is no frequency here, Bible underscore frequency. Okay. So what I'm only trying to say is, I'm going to browse to localhost, my file system. I'll browse the file system, and I want to show you that I don't have any of those table data here. Okay, just remember this screenshot. I have just 4 items here. Okay, and then once I import, I should see some data here. So is it are you guys following me? Are there any questions? Because the next few steps are key. If you try to follow me, then the objective of this particular session is achieved. So that's why I'm trying to show very hands-on. Okay, any questions?
No.
Okay, so what we are trying to do here is, I have some data, and the data is there in MySQL database. Okay, I've shown you the data. It is there in tables. So the name of the tables are shake underscore frequency and Bible underscore frequency. That is the kind of data that I have. I want to take this data and assume that this data is in the enterprise, right? This data is in the enterprise. So this data could be related to orders, it could be sales, it could be marketing data, it could be customer relationship data, it could be financial data, it could be anything. It could be the product data from a product table, it could be, any data that is related to financial systems. This data I want to move to Hadoop file system. That is my goal. Okay, that is my goal. So for that, what I'm trying to do, basically what I did, since I didn't have the data in MySQL, somehow I got the data from somewhere and I copied the data into MySQL. Now the next step is, I want to move this data to Hadoop file system. Okay, so how do I do that? Okay, so this, if you want to do that, we will follow very simple commands. Okay, so I'll go to scoop. I'll go to scoop, Hadoop, and then scoop. So I'll just say scoop. You should see, sorry, if you say scoop help, you would see the commands that are available. Okay, so just see here, these are the commands that are available. Scoop command arguments. Okay, so if you see here, scoop available commands are code gen, create hype table, eval, export, help, import out tables, scoop job, scoop list databases, scoop list tables, scoop merge, scoop metastore, scoop version. So if you want to see what it is, you can just say minus version. You would see what kind of version that I am using. Oops, I think it is minus version. Oops, strange. Display version information. No such scoop tool. Minus version. Anyway, so it should have given me the actual version. I'm not sure, but anyway, doesn't matter. So let me go and start doing something. See, if I want to see from scoop, I want to see what are the list of. Okay, so this is what I don't want to run here. Okay, so I'll run it here only. Okay, so what is this command? This command is scoop. Okay, list databases that you see here. The list databases command, and I'm connecting to JDBC MySQL localhost, and I'm giving a username root, and I'm giving a password root. So what I expect is, I expect the list of databases that are available in the MySQL system. So you see here, there are about 6 databases. So I can use the same command here under MySQL, and you would see the same output here. Show databases. If you see, I have about 7 databases, and you see those 7 databases here. Okay. Now the next command I want to show you is how I can list tables.
What did you write JDBC with?
What is that?
Why did you use JDBC?
Okay, I'll come to that. I think I have list. Okay, I'll take the same command and modify it. So I want to see list of tables under scoop underscore test. Right? Scoop underscore test is the database. I want to see list of tables under this. Right? You would see that there are about 4 tables. So if I go to MySQL, I can verify whether those tables are really there. So these are the 4 tables that are available. I'm able to see these 4 tables through scoop. So the question was, why am I using JDBC? So if you look at the slides that we have used, right? you look at this connector, right? This connector is JDBC connector in this case. Okay. So how does the map task get the data from the database? So it has to use some mechanism, right? It has to use some mechanism. How do you use the mechanism? So what the machine is? The machine is not localhost, but it is somewhere in the some other data center. I need to get the data, so I need to connect to the database. How do I connect to the database? Okay, there are a couple of, you can use VB, you can use JDBC, things like that, right? So in this case, I'm using JDBC. Is that clear?
Yes, yes.
Okay. So I hope you can stop me if you're not following. Okay. So I showed you list of tables. I think list of tables is here. I showed you list of tables. I showed you list of databases. And I'll send you this file so that it's easy for you to just walk through this and then try out some of these. Okay. So earlier this will not work. Okay. Now what I want to do is I want to import data from a particular table into Hadoop file system. So how do I do this? I use the import command. So be careful. Just watch out this command. I will run through this command one more time. Oops. Okay, so let's walk through this command. Scoop import, right? You have seen the scoop, right? Scoop help. See scoop help. So you see there is an import command. There is an import. There is also import all tables, right? See here. So I'm trying to use import here. So I'm trying to use import. I'm going to connect to database called scoop_test using a username and a password. Username is root and password is root. Now I'm going to import minus table Bible_frequency into Hadoop file system. So I'm going to import this table Bible_frequency into Hadoop file system. Okay. Any questions on this? I'm going to press enter and see what happens. Okay. So the expectation is that it should use a map reduce job, right? And it should connect to the database, get row by row, or get the input splits, and then create a map task for every input split, and then for every input split, read row by row, and then push that data into Hadoop file system. So now here you can see I have processed about 14,330 records using a map reduce job. Again, remember, scoop is nothing but is built on the top of map reduce. So this is built on the top of map reduce because if there are huge databases, you will be able to transport this data parallelly. You will be able to do a parallel copy of data from database systems to scoop. Now this particular table, my Bible_frequency is copied. So I want to show you that. So I'm going to refresh here. So you would see Bible_frequency here, that is just copied. Okay. And then you can see that there are multiple parts to it. So it is partitioned. It is partitioned by some partition size. And I think I'm not sure how it is partitioned, but definitely it has created data. So now if you see here 2, 0, 2, 0, 0, 2783001, that is the data that we have, right? And then you have part_m. Okay, so you would see that the occurrence of the words are here, the count and the words. Okay, so this is how you can import the data from a enterprise database system like relational database system, in this case SQL, into Hadoop file system. So is it clear? Any query here? I can run one more time. Instead of Bible_frequency, I can run check_frequency. I can also do import all tables, right? I can also do import all tables, and then all the tables in that particular directory, in that particular database, I can import. Right now I'm just importing table by table. So I'm running another job. So I should see that shake underscore frequency table should be there in this case, right? You should see shake underscore frequency table. So excuse me. So the administrator, you would be probably, I'm not sure, know whether administrator does this, but sometimes definitely you have to look into the data movement from one system to other system, and then you would be scheduling jobs to push the data incrementally. You want to copy the data from relational database to Hadoop file system and vice versa. So now you can see there is a shake frequency, and then you would see there are different parts to this particular file. Okay.
Can we import world database?
Yes, you can. So you can do import all tables. Then all the tables can be imported. Okay, where is
and that? How to copy multiple databases at once?
No, that you can do. You can copy one at a time. You can do one
no,
at
but,
a time. One database. But
you had said that we can do it parallelly.
Well, then you have to submit multiple jobs. You see.
Okay.
So this is one job you submit, and the database in this case is scoop underscore test. Suppose if I have scoop underscore test 2, so just submit 2 jobs. Okay? But with what I meant was within the database, if you have multiple tables and huge number of tables, then map reduce happens parallelly.
Okay.
Okay, sometimes you would be little confused in the sense that if in this case, right, when I tried this, I had a problem because the database, when you export it to either UTF-8 or some other character set. So in this case, my database MySQL underscore dump was exported with a Latin character set. Okay, when I import it, you can also specify what character set you want to import. Okay, just as a minor point, but it's very important for administrators. Right, what I'm trying to say is sometimes people use different character sets in storing database, and most of them are nowadays using UTF-8, but unfortunately this particular database is using Latin 1 as the character set. So at the time of import, you can also specify what character set you want to use at the time of importing. That's what it is. So there is one more point which I didn't cover. There are 2 important points for this to work. Right? For this to work, you need to download. I think somewhere it is there. Okay. For this whole tool to work, so download the MySQL JDBC connector and copy the jar file in scoop underscore home/lib directory. So this is the point that you should remember. I'll show you what I meant by this. Now if I go to ls-al $scoop underscore home/lib MySQL connector. So this particular file, MySQL connector, right, is a JDBC. I download this and then copy it under scoop wherever you have installed scoop. In my case, I have installed scoop under soft directory, and then there is a scoop here, right? Under lib directory, you have to copy this file. So if it is a Oracle connector, you have to copy Oracle connector, oracle-jdbc.jar into this lib directory. That is one step that I forgot to tell you guys. Okay. And then suppose if in this case, sometimes what happens if you're using MySQL dump, right? Especially in case of MySQL, you have to also make sure. I think there is one. Yes. I'll set it up here. So Okay, so in case of MySQL, we'll be using MySQL dump. Okay, MySQL dump is being used for transferring the data. So the tool assumes that you have MySQL dump under user bin MySQL dump. In Linux or Mac, it is expected that it is there in user bin MySQL dump. So when you install MySQL on your system, you would see this user bin MySQL dump. Okay, so that is required for copy. And then if you don't have it, you can create a soft link to that particular directory like this. Okay, this is an optional step. Okay. So there is another thing here. I will show you this command. So next class we will definitely go through this Hive thing. Okay. So what I'm trying to show you here is, okay, I have Hive installed in my machine. Okay. So to invoke Hive, basically how do you install Hive? That we'll go through the next class. So I'll just say Hive. Okay, Hive is nothing but similar to MySQL. So I can just say show tables, right? Similar to MySQL. I can just say show tables here. Right, similar to MySQL, I am showing there is a table called merged. I can say drop table merged. Okay, so there are no tables here. Show tables. I don't have any tables. Okay, so before that, what I will do is I'll just remove whatever I imported. This I'm removing Bible underscore frequency and shake underscore frequency. Okay, all right. Now I will show you one more thing. I'll go here, I'll go to Hive, I'll go to warehouse. Okay, here I can see some things here, union test and all that, but forget all this. Then let's go ahead and copy data into Hive tables. Okay, so what I'm trying to do now is that I'm still trying to import the data into Hadoop file system. But there is a change. The change is that I am importing the data to Hadoop file system, but I'm trying to create a Hive table. I'm trying to create a Hive table. So in this case, you see there's something called minus Hive import. Direct means, that is direct in the sense directly from the table, read the data directly from the table without any pre-processing, and then all the fields will be terminated by /t. The lines are terminated by new line. So what does this mean? This means that I am still using the same import command, same JDBC connection, same username, same password, same table, but instead of importing into a flat file, I'm importing into a Hive system. So what is a Hive system? Hive system is nothing but, next class we will learn more about it. Just for now, you remember, Hive system is nothing but it is a SQL like kind of query interface to Hadoop file system. So this is developed by Facebook. So why they have developed it? They found that writing MapReduce Java programs is very difficult. Even an ordinary Java programmer, even for him with 1 year experience, it takes a lot of time for him to learn MapReduce and use MapReduce Java programs. Hence, Facebook thought, let's implement a tool. So what they did, they built Hive. What does Hive does? You don't have to write MapReduce programs, but write SQL queries, so that the business analyst who knows SQL already, or 1 year programmers who knows SQL already can start using these big data tools, and in this case Hive. So they developed Hive. So what is Hive? Hive is a SQL like query interface for the Hadoop file system. You can query Hadoop file system using Hive. Okay, that's what Hive is. Introduction to Hive. We will learn more tomorrow. Now what I'm trying to say here, I'm trying to import the table and then also at the same time create a table in Hive. Okay, so I will show you that. I'll just say think I don't have. Okay, so I'll do it right. I'll just say Hive here. I'll say show tables. So you can see there are no tables here. Okay, so there are tables. There is one table called docs. Okay, but there are no table. Otherwise, there are no tables here. So now what I will do, I will run this command. What I expect is you should see a table created here. Okay, so I'm running enter here. Watch out, I'm running enter here. So again, this is a map reduce program is being run, and just like before, the data is copied to the Hadoop file system, no change. But in addition, a table gets created in Hive. That's what this program does. So you see here, there is a Bible underscore frequency. This is the file in the Hadoop file system. This is no different. You can still see multiple parts are created here. There is no difference. Okay, there is no difference in terms of copying the data to the file system. However, there is one difference. That difference is this. Now we can say show tables. I am expecting a Bible underscore. Whoa, it's not there. Okay, so maybe I'll just run one more time. So I was expecting a Bible underscore frequency table here. Somehow it didn't work. I don't know why. It should have worked. So I can see that it is part of the Hive. Okay. And so it is copied. Okay, so I think it's slightly. I mean, the reason why it is little it is not showing is I will tell you later. When we discuss about Hive, we will do that. We will show you. I will show you why this has not come here, but I can see here. Okay, now I can say select count star from Bible underscore frequency. So again, this is basically when I issue a Hive query like this, select count star from Bible underscore frequency is a Hive query. So internally it is running a map reduce job because I'm not doing a select from MySQL database, I'm doing a select from Hadoop file system. So internally a map reduce job is run and the output of map reduce job is shown here, and I have 14,330 records. So you can see that the data has been copied. The data has been copied from MySQL database to Hadoop file system. At the same time, data is available in Hive tables. So I can query the data Bible underscore frequency just like any other data. Is it clear? Any questions here?
Already.
So what we did today, so we discussed about the data management aspect of Hadoop. So generally in an enterprise, especially in financial sector where you have a lot of banks, so they want to move log files from the database or from somewhere in the enterprise systems to Hadoop file system for doing analysis at a later date, right? From doing analysis at a later date. So what they do is they use these tools to move the data. So if you want to move the regular data, in the sense any data or any files data, you can use Hadoop fs commands to move the data. But if it is a database, you can use scoop. So that is what we discussed. So what we did is we have a data, in this case my SQL database. I have some data, I have two tables. I showed you how to import the data into Hadoop using scoop. That's what we did today. Okay. And so there are other commands you can practice. So this particular one is very extensive. It all depends on how much time you can put in. Okay. And you can spend at least another, you can spend only another 1 month if you want, only in scoop, trying to understand what it is. Okay. So you can run some queries. You can run some queries on Hive. This is what it is. Okay. I can also merge join tables in Hive. That's what this is. Okay. And you can do an import all tables. I was talking to you. Somebody was asking, can I import all the tables? Yes, you can import all the tables from MySQL. Okay. Then you can also see whether that particular table has actually come or not. Then you can also do an export. So not only you can import, if you have a data in the Hadoop file system, you can also do an export. You can do an export, okay, into relational database. In this case, if you see, I'm doing an export and connect to the same JDBC, okay, JDBC MySQL. In this case, the MySQL is in Amazon Cloud. In this case, you see EC2-176.34.66.213. European Union-West-Compute.Amazon-AWS.com/test. This actually is a cloud server. It is there in Amazon Cloud. There I'm and the database is test and the table is export test, and directly you copy. Username is scoop -p. You'll ask for password, and then the export directory. The export directory is -export directory user Ubuntu scoop. So this user Ubuntu scoop should be available in Hadoop file system. So from Hadoop file system, I'm exporting the data to database. Okay, is it clear? So what we said is you can import data from relational database to Hadoop file system. Now what we are also saying is you can export some data from Hadoop file system to relational database. Why is this required? Sometimes you want to present the data to users, the business users, on a nice web interface. So if you want to do that, generally the processing happens in Hadoop, the output happens in Hadoop, and then you export that output of Hadoop file system or Hadoop to some relational database. From there they will have a web interface that can show the data from the tables to the UI. So that is how export is being used. Okay, so there is one more command. Sometimes in the interview question they may ask you, okay, so what if I have, when you are doing an import, right, or when I'm doing an export, what if that particular record already exists? Okay, so the question here is, I have my database and I'm trying to export the data from Hadoop file system to relational database. In that relational database, I'm doing an incremental export. So which means some data is already there, and it so happens that that particular row is already there, and I'm trying to import that row. So what happens? Generally, if it is a primary key and it has to be unique, it will fail. But if you really want to do an update, so there is a command here. You can see here. You can use -update key. You can use -update key option to scoop, and then you specify what is the primary key for that particular table. So in that case, you will see that not only just regular export, I can also update some columns in the database table. That is how it works. Okay, is it clear? Is it clear?
Please explain again.
Okay, so what I'm only trying to say is, if your database has tables already and those tables have rows already, and you're trying to export some files from Hadoop into these tables where there is already some data, and it so happens that your database table is having a primary key, right, and you're trying to create duplicate records. So what happens? The export is going to fail, because Hadoop will try to create another row with the same ID, same primary key, so data export fails. In such a case, what you could do, you could use the minus update key option. In that case, what Scoop does is, instead of issuing insert statements, it issues update statements, so that the import can be successful. The export can be successful. Is it clear?
Yes.
Okay. Okay, so there are other small things. You can create a job in Scoop. Okay, so it's a MapReduce. Since Scoop is running on MapReduce, you can create a job. So what does that mean? Let's say you're an administrator and you are asked to copy the data every week on Friday night, midnight, 12 o'clock. You want to schedule a job to copy the data from a financial system to Hadoop file system, right? So you will obviously be Friday evening, you would be probably having nice party at home. You don't want to spend your night there. So what you create a job. Okay, you create a job and keep it, and that job you can run at midnight, Friday midnight, using a scheduler. In Unix you can use cron scheduler. Okay, you can use the cron scheduler. So this facility is available. So what facility is available? The facility to create a job before and then run that job at a later point of time. So how do you do that? You create a job here, Scoop job, create my job. It is not going to run it. Okay, it will only create a job. So you're trying to create a job that says you connect to the database and import this table. That's all it is saying, right? And then you can query for the list of jobs, and you can also do a show job, and then you can also execute a job. So this is the command to execute a job. This command you can put it in cron job, and then you can specify the time, and then this particular job can run at Friday midnight 12 a.m. so that the data can get imported. That's what is this particular thing is doing. Okay, so is it clear on the jobs? That's an interview question. If you were to schedule a Scoop job, what would you do? You just create a job and then run that job in using this command, Scoop job minus exec job. That can be run from any other scheduling system. Okay, that's what is the answer should be. Is it clear?
Yes.
Okay. So while doing an import, you have another option called minus query. So you can do an import by using the result of a query, right? So what we did earlier, we just did connect to the database and then directly, without any query, minus direct, without any filtering, we copied it. What we are trying to do here, you're trying to query the database using a specific query. In this case, I'm trying to join two tables with some conditions, okay? And then I'm also trying to split the data into multiple tables, and the splitting happens using a.id key, and the target directory where I want to copy the data into Hadoop file system is this join results. Okay, so I'm trying to import the data from the database into the file system, and the file system is the target directory. And how do I get the data? I use this query to query the database and get the result set, and that result set is split using this a.id, and that data is copied to Hadoop file system in user foo join results. So that's what this is taking. So this is another example for split. Then if you don't want to import as a text file, what we have seen, if you see here, this Bible_frequency is nothing but a text file. Okay, but sometimes it is not efficient to process text files. If you want to create a sequence file, right, you can do the same command you can run as the output of, or the in Hadoop file system you can store data as sequence files. Okay, sequence files are nothing but the files are indexed using 1, 2, 3 like that, and then the value is going to be file content. That is in what you are saying is you can also provide a where class to scoop where only if that condition is satisfied data can be copied. This is, and then here you can also see minus append. Append means add to the existing table. Okay, and you can also import the data using some query by specifying a where class. This file is available to you guys. I will send this file today, and that is the end of the session. Any questions? Any questions?
No.
No.
Okay, so there is another tool, Flume, which we don't cover in this. The Flume is similar to Scoop, but Flume has a different architecture. Okay, Flume has a different architecture, FLUME. There may be other tools, but people use Scoop more frequently than others. So what does Flume do? Flume is also similar, but it has again a completely different architecture, and it is also distributed. So you should go to Google and say Flume, and then try to understand what Flume is. Okay. Thanks, guys. We will see you tomorrow again. Bye.
Thank you.
Thank you.
Thank you. Thank you.
The organizer has ended the session, and this call will be